Welcome everyone to our last ELOC session of the year. This is now going to be one of the final sessions of this first round of ELOC sessions, and of course today we have Professor Jon Star from Harvard Graduate School of Education here with us, which we're very pleased that he could make it. And the title of his presentation will be New Directions in the Study of and Assessment of Mathematical Flexibility. And to continue with the tradition of introducing our speakers, both in numbers and words, my animations don't work, it seems, so you just get to look at all of it at once. So in numbers, looking just with Scopus, we see that Jon has almost 2,500 citations from 78 articles and over 91 co-authors. So clearly someone who is very prolific in the field, and we're very pleased to have such expertise here with us. And then to go with the, I forgot the name of it, it's not an anagram, but the listing out of qualities. Wanted to, one thing I noticed about Jon already in my first interactions with him, I was going to use the word editor here, but here I use educator because my first interaction with him was when he was the action editor for one of my first submissions to an academic journal. And I was really surprised by the thoroughness of his work, but also what I saw is his kind of editorial process that wasn't just sort of prescription, but actually guiding and developing of the manuscript with the authors. And I really appreciated that approach to his editorial work, where I saw it more as sort of, a guiding educator, and that was really impressive. But also, of course, his dedication to math education in general. For instance, he has to leave us at the end of the session today. He's going straight to the math classroom, and I'm really kind of impressed and see that as an incredible dedication to his education, that he still wants to engage in the math classroom kind of on a very fundamental level. And that's, I think, one of a great quality of him. And of course, then the leadership involved in his editorial work, where he's still clearly contributing to many different journals, including Cognition and Instruction, where I first encountered his editorial leadership, and also then as the leader of two of the doctoral programs at the Graduate School of Education, clearly a leader in the field. Another thing is his ability to be observant. I was going to use engaged, because one thing that I'm always impressed by when I'm in sessions with him is his ability to kind of ask poignant questions in meaningful ways that both lift up the kind of open questions, but in a very constructive way. And I think that shows his observational skills, being observant. And finally, of course, working in the space cross-disciplinarily, that not just sort of being constrained to one feature of mathematical learning and instruction, but working both with classroom activities and fundamental psychological processes and this sort of thing that I really think is incredibly valuable for the field at large, and not just sort of fitting into one box clearly, his cross-disciplinarianism. So yeah, with that said, I guess I will go ahead and turn it over to Jon, and so welcome. Thank you.
Great, thank you, Jake. It is great to be part of this very special colloquium series in honor of such a special person in our field, Erno. So I'm delighted to be with you here in what is an early morning for me and an afternoon for you. And I'm very happy to be speaking to you about new directions in the study of and assessment of, and in this talk, you'll notice I changed the title to say procedural flexibility rather than mathematical flexibility, but I'll talk more about that in a moment. So here is the plan of what I'm going to talk about today. I'm going to begin by just getting us oriented with flexibility, and then talk about some individual and disciplinary influences on flexibility, followed by the main part of the talk on measuring flexibility. In this talk, I hope to share some thoughts with you about procedural flexibility and its assessment. Rather than a traditional empirical talk, this is going to be more of a reflection by me about the state of the field and the state of my research about measuring this important construct. And as such, it's important that I be clear in the beginning about some basic premises underlying my remarks, as I've shown on this slide. So in order to study procedural flexibility, we need to have a reliable way to measure it. And efforts to measure this construct begin with a careful definition, as well as working through some important definitional corollaries. Note that in the field of math education, I'm not sure we have always been diligent in our attempts to identify good measures for constructs of interest. Although I won't be speaking about this today, there are several constructs in our field that have been widely studied by many researchers, but which lack agreed upon and usable measures. I don't want this to be the future of procedural flexibility as a construct. I want us to have good measures. But to do so, it's important that we first think about how to define this construct and the implications of this definition for how we measure it. As interest in flexibility continues to grow in the field, I seek to keep our attention focused on developing good measures, which will have very clear and big benefits for both research and for practice. So let's jump right in with some initial thoughts about definitions and examples. The process of developing an assessment for procedural flexibility begins with a deliberate choice about the terms used to name and define this construct. And as is quite common in our field, there are many choices with respect to terminology. For example, there is something called cognitive flexibility, which in the way it's defined does have some overlap with what I and others talk about with respect to flexibility in mathematics. This term was widely used in the 90s and seems to have been making a resurgence recently with renewed attention on executive functioning, of which cognitive flexibility is considered a part of. But I will not be using this term because it's rather broadly used across many different fields, and it is rather narrowly operationalized as task switching these days, which is related to flexibility, but not exactly what I'm interested in. A second term that's widely used is adaptive expertise. And I know that there may be some members of you that use this term in your thinking about things related to flexibility. And I also know that Lieven Verschaffel, my colleague and friend, gave an earlier talk in this series where this is what he and his team use. So certainly there is a connection between adaptive expertise and what I think of as flexibility, but I'm not using this term either. And the reason why is it's often used in elementary math learning, and I am primarily focused on secondary, middle and secondary school learning. And in addition, I steer clear of adaptive expertise because it is used as a dichotomy in our field as a contrast to what some call routine expertise. And this dichotomy of adaptive expertise and routine expertise is related to the dichotomy between conceptual knowledge and procedural knowledge. And that's a battle that I fight elsewhere and not within my study of procedural flexibility in my definition. So I will not be using that term. And it's also something that I haven't seen very precise operationalizations of. A third term that I do sometimes use and was in the original title of this talk is mathematical flexibility or strategy flexibility. But I've steered away from that recently because I found that it's very broadly applied as well. And I've also been challenged in that broad application of this term to really precisely operationalize it, which is a goal for my measurement. So that has led me to continue to use procedural flexibility. So this is where I've landed. And the definition that I use is listed here. It's two parts: knowledge of multiple strategies and the ability to select the most appropriate strategy for a given problem or problem-solving circumstance. And as I'll talk about later, I like this definition now and this term because I have been finding ways to clearly operationalize it, which is important for measuring. I'd like for you to think with me about how we might operationalize the definition of procedural flexibility. And I'm going to do that by looking at some examples. As you look at these examples, consider the question that I have put on the slide here. What challenges or questions about defining and operationalizing procedural flexibility become evident as we look at these examples? So let's begin with the first example. And this is a problem I use a lot in talks. It's just a basic linear equation. There is a standard algorithm that is taught in many countries around the world for how to solve this problem. And there it is. But of course, this is not the only way to solve that problem. And among the other ways of solving that problem, we could leverage this divide to both sides step, which in the standard algorithm occurs as the last step, but it can be done earlier in the problem solving process to end up with this solution, which one might argue is better. If I change the problem slightly to change the 15 to a 14, then the standard algorithm can still be used, as well as this alternative strategy, making use of that divide to both sides step. But perhaps one might argue that because of the presence of fractions and in the eyes of students, that the first strategy could conceivably be better because it involves less work in the adding and subtracting of fractions. Now, you might not agree with me in my claim about which strategy is better for either of these problems. But what I hope you see is that even in this first example, we've already stumbled upon a very tricky issue that seems core to procedural flexibility. What does it mean for one strategy to be better than another one? So let's keep wrestling with that issue as we look at another example. So here's another linear equation, and here is a standard algorithm that can be used to solve this. But this is not the only way to solve that problem. Among the other ways, we could leverage the use of combining like terms, which is done in the standard algorithm with 4x and 3x, but could also be done with the 4x plus 2 and the 3x plus 2. We can also make use of this divide to both sides step and do it earlier, and that results in this strategy, which we might argue is better. But perhaps this example raises another question. What do I mean by the standard algorithm? What strategies fall within the umbrella of the standard algorithm? Is the standard algorithm for this problem the same or different than the standard algorithm shown in the previous slide? So we're accumulating some interesting questions. Let's look at another example. Here is a fraction addition problem. And here is a way that a student could solve this problem that we might categorize as the standard algorithm. It's finding a common denominator of 9. But many times students will not find a common denominator of 9. They will find a common denominator of 27. So what is this? Is this the standard algorithm? Is it worse than the standard algorithm? There's another way that this problem could be solved, and it might recognize that if you switch the order of the two addends in the middle, then you obtain two easier to add pairs of fractions. So is this a better strategy? So should we consider the strategy of finding a common denominator of 9 to be different from the strategy of using a common denominator of 27? If so, is one better than the other? These are difficult questions, but unavoidable. And one last example. This is an addition problem. A standard way to approach this addition problem might be just to move left to right. But an alternative way might be to recognize that if you switch the order of two of the addends, then you obtain two relatively easy to add pairs of numbers. Would we say that's a better strategy? Well, what about if a student does switch the order of the two add-ins and leverages the first pair as an easy to add pair, but then goes left to right. What is that? Is that worse than the standard strategy? Is that better than the standard algorithm? Are these three different strategies? Why or why not? And what are our grounds for claiming that one might be better than the other? So these are tough questions. As I hope became apparent in those examples, even when we have a clear definition of procedural flexibility, there are still some challenges in thinking about examples and operationalization that need to be addressed before we can seriously think about how to assess flexibility. In particular, given this definition, there are two very important issues that we must figure out before thinking about an assessment of procedural flexibility. The first of these issues is what I call the different question. And the different question asks, what does it mean for a strategy to be different than another strategy? Different according to whom, and different by what criteria? And the second question I call the best question. What does it mean for a strategy to be the most appropriate or better for a given problem? Most appropriate according to whom? And by what criteria do we judge it most appropriate? And here I list a number of terms that are related to this question, including efficiency, ease of use, absence of errors, elegance, cleverness, suitability. There are many that are related to this determination of what it means for a strategy to be better than another one. These different and best questions must be addressed in any operationalization of procedural flexibility. And so let's take time to wrestle with these questions now. So as we do so, we're going to do so by considering what I call individualistic factors and disciplinary factors in the discipline, and that refers to the discipline of mathematics on those two questions. So think about some sort of axes here where at one end of the spectrum, we might answer these two questions from a purely individualistic perspective, and at the other end, we might answer them purely from a disciplinary perspective. So let's just wrestle with what that would mean. So from purely individualistic perspective, what that might mean is that if the student who produced strategies A and B believes that strategy A is indeed different than strategy B, then strategy A is different than strategy B. And similarly, if the student who produces strategy A and B believes that strategy A is better than strategy B, then strategy A is indeed better than strategy B. I believe that such a completely individualistic perspective on procedural flexibility is a bit of a dead end or non-starter. And my hunch is that many of you might agree with me on this, and so I'm not going to dive too deeply into a justification of this now. But basically, if all it takes to have procedural flexibility is for an individual to believe that they are flexible, then procedural flexibility is probably a fairly meaningless and not very worthwhile construct for researchers and practitioners. On the other hand, if we consider a purely disciplinary perspective, that might look something like this. If an expert believes that strategy A is different than strategy B, then strategy A is indeed different than strategy B. Or if an expert believes that strategy A is better than strategy B, then strategy A is indeed better than strategy B. Now, it isn't clear to me whether a purely disciplinary perspective on procedural flexibility is the answer either. But this is something we need to consider more fully in the context of some additional examples. As we look through some more examples, I hope you'll think about how my research team and I have thought about the different and the best questions, and how we've tried to consider both individualistic and disciplinary perspectives. In particular, consider this question as we look at a couple more examples. How have these answers to the different and the best question resulted in an operationalization of procedural flexibility that can be reliably and consistently used, and that adequately appreciates individualistic and disciplinary nuances? So let's look at these examples again, and these are problems that you've already seen, but I want to look at some student work now. So when we gave this problem to students in one of my studies, what we did is we first gave them the problem and asked them to solve it. And then they did several problems in this way. And then later on, they were asked to solve the same problem, but using a different method than the one you used before. So take a moment to look at these two methods. So the question that we first need to ask ourselves here, are these two methods different? Well, from an individualistic perspective, we might say yes. This is how the student responded when asked to produce a different method. So in the student's mind, the second method is different than the first method, and so therefore it is different. But I think if we were to poll each other on this, we might say no, that these two methods are not different, that they're both the standard algorithm, given that they're writing the same steps in the same order. And this is what my team ended up deciding as well, that these two methods are not different. All right. Well, let's look at two more methods. What about these two methods? Are they different? I'll give you just a moment to look at these. So this one feels a little more straightforward, I hope to you, that most people, when they look at these two methods, would say, well, yes, these two are different. The second strategy begins with a different first step. So these are different strategies. But once we establish that they're different, then we have to answer the question, well, is one better than the other? So perhaps one could say, well, no, they're not better, because they both have the same number of written lines, as I've numbered here. They both have 3 written lines, and that might be some objective way that we could say they are the same. They are different, but one is no better than the other. But from our perspective, and this is illustrated in the examples that I showed you earlier, we would say the second strategy has fewer operations and performs them in a different, more innovative order. And as a result, the second strategy is indeed better. So our determination of better here relied on judgments about things like what counts as a step and how to count steps. In addition, I also think it is the case that some degree of aesthetics are unavoidable here. And these might be selective judgments that we make based on what we think is important from the discipline about a strategy. Another example, a problem that you've seen before, but let's look at some student work. So I'll let you look at this student's work for just a moment as we consider the question, are these two strategies different? So we would say that there is a possibility that one could argue, yes, there are actually several differences between these strategies. For example, if you look at the first written line on the left, the student distributed and obtained 4x plus 8. And on the right, the student distributed and obtained 8 plus 4x. So one could argue that those are different. There are other differences related to ways in which terms are collected or added or moved. So maybe that's a perspective one has, that these are different. But I think we would claim that no, these two strategies are not different, that they're both closely related variations of the standard algorithm. So you can begin to see here that in this determination, we might be viewing the standard algorithm as referring to a class of strategies. But if that's the case, how do we determine the boundary conditions for this class? I also want to point out that sometimes it may be possible to determine which class of strategies we're in merely from looking at the first step of the equation. But maybe that's not always possible. So as I tried to illustrate with these examples, these are two very difficult questions. And I'll confess that sometimes reviewers of my papers on procedural flexibility give me a very hard time on these two questions, sometimes implying that answering these questions is so inherently subjective that it's impossible to do, and raising questions about the viability of procedural flexibility as a research domain as a result. But I don't agree with that perspective. Answering these questions is very hard, but essential to the entire enterprise of studying procedural flexibility. Reflecting on these examples and thinking a bit about my research team's thinking about the different and the best questions, we can abstract a few guiding principles for how we are currently thinking about what it means for a strategy to be different or better than another. And just to remind you where this all fits into the overall plan of this talk, the story of this talk, we want to develop assessments of procedural flexibility. So we first came up with a definition that we thought was operationalizable, but then we discovered that there were these two tricky questions that we first had to be able to answer in consistent and defensible ways. We believe we have satisfactorily been able to do so by thinking about some guiding ideas. So with respect to the different question, as you heard a little bit in my description of the examples, we look at things like which operators are applied in what order. We do consider ways that students may make meaning from the task and the prompt. And perhaps we think about there being groups of strategies or classes or clusters of strategies that may be similar or the same. With respect to the best question, we look for ways in which the affordances offered by a strategy seem to be a match for the conditions present in the problem. We also consider the students' meaning making about better and different, but also we find it necessary to embrace this unavoidable aesthetic considerations or judgments that factor in to the evaluation of any strategy. And I hope you can see that these things that we rely upon are neither a purely disciplinary perspective nor an individualistic perspective, but we recognize the need to draw from the full spectrum in making answers to these difficult questions. Stepping for a moment out of the issue of how to measure procedural flexibility, our reflections here on how to answer the different and best questions also have prompted us to think a bit more about the construct of procedural flexibility generally, what it is and why it is important as a mathematical outcome. And I want to share two such reflections with you here. The first I call the need to nudge. And what I mean by that is that recently I've noticed, especially in the US, that there is an overweighting of individualistic factors and a reluctance by teachers and in some cases researchers to make evaluative judgments of student strategies. What this means is that many teachers might believe that any strategy that a student produces, if it's done correctly and arrives at the correct answer and can be explained, is fine. And that teacher may not see value in making any evaluative judgments or comparisons between two student strategies, implying that one might be better than another. I feel like, and incorporated within the notion of procedural flexibility, it's central that these types of judgments are important because there are, in fact, disciplinary norms or ways that experts can and do evaluate the appropriateness of strategies, using words like, for example, suitability and elegance. This is not to imply that this is always an objective and clearly definable thing, but it is something that is core to the discipline, that we have discussions about how to evaluate the relative merits of strategies. As an example here, I'd like you to consider the problem that I'm showing on the right, which is a student's rather unusual strategy for solving one of the problems that you've seen. And my argument is that it is part of our job to nudge our students toward better strategies and better strategy choices, which amounts to essentially a calibration with the norms of the discipline. And if a student produces this strategy, then it is part of our work to try to get the student to understand what aspects of this strategy can be optimized or improved, and why those can be optimized or improved. It is not the case that we want every student to always use exactly the same strategy that is the only best strategy, but if a student is solving a problem like this, we do need to nudge them forward, I would argue. The second observation here is that these two questions, different and best, are really referring to non-overlapping clusters, or largely non-overlapping clusters. What I mean by this is that it's helpful to think about the answers to these questions as having somewhat probabilistic answers rather than definitive and objective yes/no answers. So for example, think about some continuum here where strategies might be considered increasingly different or better, let's say. And we might view our task when given two strategies is trying to answer the question, is strategy one different than strategy two? With the idea being that we would be making an individual judgment about these two strategies that has a yes/no answer. Yes, they're different. No, they're not different. Or the same with better. Yes, one is better. No, one is not better. But the way that I have come to think about this is that I consider strategy one in this case to actually be part of a class of similar strategies, a cluster that perhaps I think about as the standard algorithm and its variants. And what this task, what the different question and the best question are really asking me to do is consider whether strategy two and the set of strategies that fall into its class of potentially better strategies are distinct or better than the ones in the standard algorithm class. So stated somewhat differently, what seems most important about being flexible is being able to identify a set of strategies that's different than or better than another set of strategies. The boundaries of these strategy clusters are necessarily going to be a bit fuzzy, but this is unavoidable within the discipline and something that we must directly engage with. It is also the case that there are going to be strategies where this is very hard, if not impossible to do, because they may blur the boundary between these two classes. And similarly, there may be other strategies that don't fall into these or other classes at all. But for me, this is a helpful way to think about what we're really trying to answer with the different and the best questions, and what is core to being flexible and having knowledge of multiple strategies in mathematics. All right, so where are we in our preparatory work now for thinking about how to assess procedural flexibility? We have this definition that we came up with. We've identified these two very challenging definitional questions that are unavoidable that we need to wrestle with. And we hope that we've identified some sort of path forward for answering these questions productively and consistently. So we've arrived at a time to think a little more directly about how we might assess the two aspects of the definition of procedural flexibility that are incorporated in my definition. As a relatively new construct, or at least operationalized as it currently is, it's a new construct, the field has not settled yet on a common or agreed upon way to measure procedural flexibility, nor have I in my own investigations of this construct. With the reminder of the definition and to the need to assess both aspects of procedural flexibility, I wanted to share two broad classes of assessment types that we have investigated and explored in my prior work. The first is we've asked learners to answer forced choice response questions to assess their flexibility, and this involves reacting to or analyzing other strategies that might form some sort of indirect evaluation of procedural flexibility. And the second is we've asked learners to solve problems, often in multiple ways, where we've asked them to generate their own strategies to more directly indicate their procedural flexibility. For each of these two approaches, I want to reflect with you on some examples, successes, and challenges that we faced in these assessment efforts, as well as thinking about what might come next. So starting with the first one, this is where we ask learners to answer various forced choice questions. So for example, here's a sample item that we've used in prior work. And this assesses learners' knowledge of multiple strategies. And there's another question that goes with the same prompt that asks for them to make a judgment about a strategy, and that would be assessing the second part of the definition. So you can see in this item that the learner must think about Kim's strategy to understand what Kim has done, and then to make a judgment about this strategy. As another similar example, here you see the learner must consider 4 different approaches from Anna, Ben, Chris, and Drew, and think about which of these is the best for starting this problem. Similarly, this is from an assessment that we gave to Chinese students. And by the way, this is why the font and the small details of some of the strategies are a bit different from prior examples, because they're modified to match the Chinese context and what they're used to seeing. But here are 3 strategies for the learner to examine and make sense of before rendering a judgment about which is best. And finally, most recently, here is another way that we've asked learners to do the same thing, where we provide learners with 3 strategies here about this problem that you've seen several times now. And then we ask the student to provide some sort of goodness rating for each method. So reflecting on these types of forced choice response questions, where the learners indicate their knowledge of multiple strategies and the ability to select the most appropriate strategy by answering forced choice questions about other strategies, I want to think about some of the things that seem to work well, some successes with this approach. And I'll highlight here that it's been very instrumental to us as a research team to write and iteratively improve these types of questions. It's forced us to think more sharply about what procedural flexibility is and how to measure it. So that's been very good. But I want to note that this approach has also posed some challenges. In particular, as I noted a moment ago, this approach and this type of question requires that learners make sense of another strategy. And so it raises a question about whether this type of item is measuring procedural flexibility as it's intended to do, or whether it's measuring learners' ability to make sense of other strategy. So students' rating of other strategies may not be optimal, as it does seem to impose an extra step in the process where students have to make sense of another person's strategy. And this can be quite challenging to do. In fact, you all may have experienced this a little bit with the examples I showed you. Sometimes you really do have to stare at the example student strategies to figure out what the student did. And we know that teachers sometimes are challenged in doing this. If this wasn't straightforward for us as experts to do, then certainly this raises questions about how relative novices would do on this type of task and whether an assessment focused solely on this type of item is the right way to go. But I will note that if you consider, for example, this form of assessing and consider this way that a student might respond, and then consider this way that a student might respond, I think that we see different things in those 2 students. There is something that we're getting out of this, something interesting and important about students' ratings and students' answers to these questions. So we can say that the first student, their responses align quite well with expert judgment, since method B was the one that experts might say is the best. But regardless, there's something interesting going on here that we do learn from these forced choice items. So now moving to the other way that we've assessed flexibility, that's where we ask students to generate solutions, often in multiple ways. So we've done this in a couple of different ways, both primarily assessed at assessing students' knowledge of multiple strategies. The first is we ask students to solve a problem and later to resolve it, but using a different way. And then other times we've asked students to solve a problem and later resolve the problem using as many different ways as they can. Now, using this type of strategy generation to assess the second part of the flexibility definition, which is the ability to select the most appropriate way, is a bit more tricky. What we've done to do that is we provide students something that looks like this, where we give them this grid or this lattice for writing their strategies. The first time they see the problem, they write their strategy in that upper left box that's designated as the first box. And then they fill in other strategies that they use in the other boxes. And so we can use what they write in the first box as some implicit indicator of which strategy they view as the best or their preferred strategy. It's the first one they chose to use before they even knew that they would be asked to solve it in many ways. So this approach, as with the forced choice question approach, has its pros and its cons. In particular, we found that asking learners to use a different strategy, to produce a different strategy, does appear to provide a good measure of their knowledge of multiple strategies. When asked to produce different strategies, students do produce different strategies, or when they don't, that tells us something about their ability to do so, we've learned. And interestingly, this also tends to push students to become more flexible. It's almost like an intervention even in and of itself. Asking students to solve problems in multiple ways can further their own knowledge of multiple ways of solving problems. But as a challenge, I want to return to something we've said earlier, is we've again been wondering whether students' beliefs about what it means for a strategy to be different and best impact their strategy generation. And that's something that we've wrestled with and has led us to consider whether there might be a third path here, a third possible way that we might assess flexibility, and one that could address the challenges I've noted in both of the prior approaches. And that third path might be to try to integrate these two features. So just to show you where we've landed about this type of integration, I want to share two sources of data that point to the promise of this type of integration. Let me just summarize why we feel like this integration approach might be valuable. If we are concerned from the forced choice questions that interpreting another student's strategies introduces some unrelated noise in the process, then maybe it would be better to use forced choice questions on students' own strategies, as you'll see in a moment. And conversely, if we're concerned from the generation questions that students' conceptions of different and best could impact their responses, then we can use forced choice questions to explore this possibility and to try to calibrate what students are thinking about in terms of different and best. So here's the two assessment ideas that we've used to draw upon this integration idea. So you've seen this lattice before, and just as a reminder, we refer to what they write in the first box as their first box strategy, with the assumption that what they write here is an implicit indication of which strategy they believe would be best for this problem. And again, recall that when they write something in this box, they do not know that they're going to be asked to fill in the other boxes with other strategies. In this assessment protocol, another feature is that after a student has filled in as many boxes as they can with strategies, we ask them to circle the strategy among the ones they generated that they believed was the best. And then finally, in our analysis, we judge with expert judgment about which of the strategies that the student produced we believe is the best. So if you could keep in mind these three aspects of this assessment for just a moment. What the student write in the first box strategy, which is their implicit choice of what they think is the best, what they circle among their strategies that they think explicitly is the best, and what we as experts judge is the best after when we do the analysis. You can imagine these three things aligning up in various different ways. So for example, they could completely and perfectly align. So the strategy that the student writes first is the one that they circle, and also the one that experts believe is the best. So I might call this, the student is internally consistent in that what they wrote in the first box and what they circled are the same, and the experts agree with that judgment. You could have something that looks like this, where the student circles what they write in the first box, so they align, but the experts didn't agree with their judgment about what was best. So maybe this is about being internally consistent, but not expert aligned. You could have something that looks like this, where the student circles what the experts believe is the best strategy, but this is not what they wrote in their first box. And fourth, you could have something that looks like this, where the experts agreed that what the students wrote in the first box is the best, but the students circled something else. So in our attempt to analyze an assessment where we did exactly this, it led to some interesting results. So if you consider, we worked with about 800 students in middle and high school in Finland, Spain, and Sweden. And just to give you some glimpse of what we found here, we found that these percentages of problems fell into each of these categories. Now, I raise this probably to note that this actually raises more interesting questions that it answers. But clearly, this is showing us some interesting differences between the ways that students are thinking about different and best that merit some exploration. For example, you see here that on 56% of problems, students are indeed using the first box for the strategy that they think is the best strategy. And then you also notice that on 83% of problems, students circled the strategy that experts agreed was their best one. So students are showing some really interesting knowledge here, and this signals to us that there might be some promise in combining the strategy generation types of problems, that's the filling in these lattices or boxes with strategies, and the forced choice questions, which essentially is the circling. So there might be some value to combining those. As a second example, you've seen this type of thing before, where we initially ask students to solve a problem, and then later we ask them to solve it using a different way. But in this assessment, which we have just implemented recently, we then give students this view of several different strategies, and then we ask them both a series of similarity ratings as well as a series of goodness ratings upon the three strategies that we've given them. So I have a stack of data on my desk using this type of assessment that is currently being analyzed. And so I don't have anything to share with you right now, but I think this gives us a lot of rich information about students' conceptions of different and best. So I'm excited to learn from this approach. This integration of generation and forced choice questions around procedural flexibility seems very promising to me, and this is where I'm currently focusing my efforts in assessment development. So as I start to wrap up, let's review where we've been in this talk. We began with these premises, where I'm very interested in assessment and trying to figure out how to measure assessment, but recognize that there's some real challenges to doing so. We came up with the definition, and then we tried to confront these challenges directly, particularly thinking about this notion of different and this notion of best, which are core to this construct, hard to assess, but not impossible. And then I began to think about ways that I could integrate both forced choice response questions that we've done in the past, as well as generation of strategy questions to come up with some integrated assessment that helps us through this very difficult terrain about what is different and what is best. So that's where the story ends for now, but I hope that there's a lot more to come in the future. And thank you for participating and for joining this talk, and thanks for your interest in procedural flexibility.
Thank you very much, Jon, about this very in-depth analysis of the tasks we can use in measuring strategic flexibility, but or procedural flexibility. But before I go to the methods you have used, I would ask a little bit more general question, and it's related to the meaning of procedural flexibility. What do you think? Why it is important that we teach procedural flexibility in mathematics education? Is it because then students can solve this type of problems better in future, or does it have any other meaning for future mathematical learning if they get training in using best possible strategies?
So thanks, Erno. Great question. So maybe I'll answer the question by first saying what I don't think is the goal for teaching procedural flexibility, and then I'll say what I do think is the goal. There's two things I don't think are the goal. So the first thing that I don't think of is the goal is I don't think this is about producing students who are better at solving linear equations. So that's a sort of purposeful choice of a domain for me, but that is not to suggest that that is the most important domain or a central domain in mathematics education. It's just a convenient domain in which to study this phenomena. And then the second reason that it's not a goal is that I don't believe that my goal is for every student to have knowledge of the one best strategy for solving every problem that they see. It is not the case that they should leave mathematics education with some sort of checklist, if you will, of when I see this problem, this is how we should solve it. And when I see this problem, this is how we should solve it. So neither of those are the point at all. But rather, I think the point is that within the discipline of mathematics, it is core that mathematicians and others that use mathematics engage in thinking about differences and similarities between strategies and making evaluative judgments of strategies. Which strategies might be better or optimal and why? That's something that we engage in all the time, whether it's in proof or whether it's in looking at other strategies. That's core to what we do. And what I'm trying to do is find a way to engage middle and secondary students and perhaps elementary school students in that kind of discussion and analysis of strategies process. So it's not as important to me that they come away with knowledge of the best strategy, but rather that they realize that this is what we do. We talk about strategies. It's not just about getting the right answer no matter how you get it. It's about how you arrive at the answer. And we care about that. And I want them to engage in that kind of conversation.
That was exactly what I expected that you are answering. That it's more about the process of thinking the alternative strategies and evaluating them, what would be the best. But then, of course, interesting question for this process of evaluating are the criteria. And in your talk, maybe I would think the expert criteria, so that what the experts value. Thinking deeper of the possible ways to define that where these expert values are coming from. So in some of your tasks, I think that experts very much value if students notice the affordances which are in these tasks, and that's probably because it means that they apply the conceptual understanding deeper conceptual understanding to notice these affordances. But then what you didn't mention, but I think would be one criteria for the expert judgments is that when we compare, particularly in a little bit more complex tasks, the procedures, in some procedures, even though they are completely correct, maybe closer to the standard procedures, the steps taken are so complex that it increases the probability of mistakes, the calculation mistakes. And in some others, it is possible to find a set of steps where there are less probability for mistakes. But I don't know if you have been thinking that as well as a criteria for expert assessments.
Yeah, so I agree that the ways in which experts engage in these conversations about evaluating strategies is very informative as we think about what that might look like in the middle school or the high school classroom. You're right that there are many criteria that experts might use to this, and experts are also going to disagree both on the criteria and on the sort of outcome of that evaluative. But that's okay. That is not a problem. It just indicates that we are going to disagree. If we use a different domain, for example, and think about art, then experts are going to disagree about which works of art are better and why and what makes them better. But that disagreement doesn't suggest that we should stop talking about the whole idea of what makes a work of art better than another. It's still a core part of that discussion. And I think in some ways that's a core part of what we discuss as well. So efficiency, avoiding error are certainly things that come up. But I'd also like to emphasize, and this is why I connected to art, there is an aesthetic component to this as well, a sort of, you know, not to get too poetic about mathematics, but there is a beauty element of this that comes into the way folks talk about mathematics. And embedded in that is also an appreciation of structure. We use the word structure a lot in mathematics to think about what we hope students see in mathematical representations, or and that kind of recognition of structure is core to these judgments about difference and better. So in some way, it's again, these conversations, these noticings about that are related to procedural flexibility and about difference and better, they have these very interesting and direct connections to core values within the discipline that we're trying to incorporate in our instruction in K-12.
Sure. Yes, I completely agree. And I think it would be a very interesting study that somebody from outside would analyze the tasks the research group studying procedural flexibility are producing, because this very much indicates what kind of idea they have about, let's say, more optimal strategies, because some elements of them are already embedded in the structures of the tasks which they produce. And so that would be an interesting task in future to do. But going to your the methods you developed, I think that the basic questions asked, that what is the disciplinary, what is the individual, is very very important starting point of thinking that, because it is also related to the kind of self-efficacy and self-confidence, so that when so that's also important aspect, that if somebody is confident that is able to apply that strategy on individual level, it is good reason to use that strategy when we compare some alternative strategy. But of course, that has been taken into account. But then this there's one thing I was thinking about, that this box model where you had different boxes where they write, and then you gave a special value for the first box. And now I think when I take into account the findings, for example, from Lieb and Versaffel's group, that the social expectations from school, the formal mathematics education, are very strong, so that I can believe that at least for some students, it is not so much based what they think is the best strategy, but what they think is the expected strategy, what is the social norm, what they put in the first box. Have you noticed something like that?
Yes, definitely. I didn't speak explicitly about other types of student beliefs other than the way students think about different and best, but I agree with you completely that there are influences that the school environment, the teacher expectations, there's a lot of influences on students' beliefs that will affect their choice of strategy. And I'll give a very concrete example of this. So I mentioned that we've collected data in Finland and Sweden and Spain. And one of the most striking things that we noticed in some of those classrooms was that students had a very strong belief that the standard algorithm was the best approach, and in fact was better than any approach that we as experts might identify as innovative. And that clearly these students had been receiving important messages from teachers and from peers in their learning of math through the years to lead them to that point. And that's not an unreasonable or irrational place to end up. The standard algorithm, if you are fluent in executing it, is very easy to do. It works on all problems. There are a lot of benefits to the standard algorithm. That's why it's called the standard algorithm. And so
yes, exactly.
I think that it's not unreasonable at all to think that students would arrive at that perspective. But I think what we found interesting is that in this particular data set from Finland, Sweden, and Spain, that perspective that the standard algorithm was the best was widely predominant and the number one belief for students in Spain, but not so for students in Finland and Sweden. And so we are not saying anything about how that belief is wrong or bad. That's a very legitimate thing to believe. It still gets us in the conversation about thinking about which strategies are different and best. But what's super interesting to me is to understand what is going on in the school system and in the educational establishment in Spain, for example, such that this is what students believe. And again, I'm not arguing that we should change their mind. I just want to understand what sort of messages, what's going on in teacher education, what's going on in curriculum, so that that's the message that's being sent. Because certainly, for example, in China, where we've also collected data, it's exactly the opposite. There really would be no students who claimed, I would believe, that the standard algorithm is best, that students are really trained very hard in China to identify sort of minute variations in strategies that can be used to save a little time on a standardized test. So there's lots of cultural variation, there's lots of influences in many ways that I find very interesting about procedural flexibility.
Yes, I think that this is something we should study more, this educational cultures and school cultures which have an influence and on the way how we in general can implement flexibility approach in mathematics education. I don't know if you know these findings from some European countries where this became quite early on a norm into the curriculum to teach flexibility, that they didn't change the school culture so that they try to teach flexible strategies in a very strict way, so that you have to learn this and this strategy, and the outcome was not so optimal from these strategies. So that's there's an interesting combination between the content of teaching and then the general educational culture which is applied.
I agree. In some ways, what I hear you saying is that it's possible to have an emphasis and an interest in procedural flexibility, but to do so in a way that's very mechanistic or formulaic.
Yes, yes.
And that's true for any goal that we would have in mathematics education. There's always
Yes.
ways to kind of oversimplify it or dumb it down. And certainly that's the case for flexibility. And what that would look like, as you point out, is implying that we're interested in flexibility just so that students know the best way, the one best way to solve every problem. And as I said earlier, that is not the goal at all in flexibility.
Yes, yes, I could imagine that in this kind of situation, students very quickly learn to notice certain hints from tasks without any deeper conceptual thinking about that, and then use them in producing answers which they believe then are according to the expectations. If the mechanistic way is used in teaching flexibility.
And perhaps we can try and avoid that also in answering John's question now in the breakout rooms, and not answer them mechanically. I'll send it in the chat now and also share my screen to show it. So thank you, Erno, and thank you, John, for the discussion and the talk. Which ways of assessing flexibility seem most promising to you and why?
Thank you for everyone for your participation today, and we will have next one in January, and actually we will have every third week. That's our plan. Like, we will continue every third week. We have a new presentation, and these will be the professors that Erno has made. So that's the list in the next year. So thank you, John, and thank you, Erno, for your wonderful discussion. And still, Erno, happy birthday. And we are ready to finish this one. And if you show the last one, we can say thank you, everyone, and have a healthy and happy and relaxing, very relaxing Christmas time. I'm sure everyone has deserved like a very nice time in between the terms. So see you all next year.
Thank you.